beneath the 600 meters of ice below me is the most important point of all.
While it's true that still waters run deep, the ocean waves hold some of the weirdest surprises. Earth's waters are vast and mysterious, so it's no wonder that explorers have stumbled upon some bizarre finds. Past studies suggested that the icy depths beneath Antarctic ice shelves were too cold and lacking in nutrients to support much life. However, a recent study brought to light by Elon Musk challenges this belief by revealing the discovery of a colony of animals on the seafloor. These creatures aren't supposed to survive there, yet here they are, caught on record for the first time. What was unearthed by researchers in the far reaches of the ocean? Why are scientists urgently seeking explanations for this discovery? Join us as we delve into the incredible discovery unearthed in the Arctic. A U.S. submarine made history back in 1958 by venturing beneath the ice to reach the North Pole, marking a significant milestone in exploration. Today, nuclear-powered submarines serve as stealthy weapons of deterrence, armed with torpedoes and nuclear missiles capable of prolonged missions lasting months at a time. For example, the UK has consistently deployed at least one submarine armed with nuclear weapons at sea since 1969. This mission wasn't just about military prowess, it also represented a scientific breakthrough, opening up a new realm for exploration and discovery beneath the Arctic ice. It served as a testing ground not only for the military capabilities of nuclear submarines but also for understanding the unique environment of the Arctic Ocean. Both the Navy and scientists gained invaluable insights into the Arctic's ecology and how submarines can operate in such harsh conditions. This access to a hostile environment has deepened our understanding of both current conditions and potential future changes in the environment. Antarctica isn't just the coldest continent, it's also a treasure trove of mysteries waiting to be unraveled. Beneath its icy surface and seas lie a wealth of strange and fascinating anomalies begging to be discovered. Despite its remote and foreboding environment, nothing is straightforward when you're in the midst of the Filchneron ice shelf, a 5-hour flight from the nearest outpost in Antarctica. Geologist James Smith from the British Antarctic Survey braved over 3 months of sub-zero temperatures, sleeping in a tent and surviving on dehydrated food. Despite it being the southern summer, he needed access to seafloor sediment trapped under half a mile of ice to study the history of the floating shelf. However, conducting the research was no easy feat. Smith and his colleagues had to melt a whopping 20 tons of snow to produce 20,000 liters of hot water, which they then poured through a pipe lowered down a borehole to reach their research site. After chipping away at the ice for 20 hours, they finally managed to break through the shelf. They then lowered a GoPro camera and sediment collector, but to their dismay, the collector returned empty-handed. Undeterred, they tried again, but once more, they came up empty. Nothing seemed straightforward in this situation. Each round trip of the instrument took an hour, adding to the challenge. Later that evening, Smith examined the video footage in his tent and immediately noticed a glaring issue. The video showed a descent through 3,000 feet of bluish-green ice abruptly transitioning to the deep ocean. Instead of the expected light-colored silt on the seafloor, there was something dark along the coasts, another 1,600 feet below. Further investigation revealed that the mysterious object was a boulder captured by the camera as it fell face-first into the sediment. As the camera adjusted and scanned the rock, it revealed something completely unexpected: life. Amidst the mostly flat seabed, there was only one large boulder. It seemed improbable to find such a feature in this location. Smith had unwittingly drilled in the wrong spot. Though not a biologist himself, Smith's colleague Hugh Griffiths from the British Antarctic Survey analyzed the footage from the UK. He identified a film covering the rock, likely a layer of microorganisms known as a microbial mat. Sturdy cylindrical sponges clung to the surface, while alien-like sponge formations and other creatures dangled from it. Wispy filaments, possibly part of the bacterial mats or a peculiar hydroid animal, adorned the rock's surface. The closest edge of the shelf, where the ice ends and the open ocean begins, is about 160 miles from the rock Smith stumbled upon. The nearest spot that could potentially provide food is hundreds of miles away. This area receives enough sunlight to sustain an ecosystem and is positioned in a way that known currents could carry nutrients to feed the organisms near the rock. As you move away from the open sea and sunlight, life becomes scarcer. According to current scientific theories, species like small mobile scavengers and predators such as fish, worms, jellyfish, or krill have been found in similar environments in previous studies. However, it was expected that filter-feeding species, which rely on an external food source, would be the first to settle here. Life often surprises us, finding its way into unexpected places. It's not the most exciting-looking rock if you don't know where it is, says Griffiths. But now that you're aware of it, your jaw may be close to the floor at this moment. How did they get there? That's just one of the many questions this discovery raises. What do they consume? How long have they been there? How frequently do these covered boulders occur in nature? Are these the same species that we observe outside of the ice shelf, or are they a different species? And in the event that the ice shelf melted, what would happen to these communities? These species are definitely living in complete darkness, which is fascinating because many deep-sea creatures also do the same thing. However, creatures that lead sessile immobile lives on the deep-sea floor must rely on a reasonably constant source of food, typically in the form of marine snow. Living things currently swimming in the water column above will eventually pass away and sink to the bottom of the ocean. Other animals pick at the bodies as they fall and begin to decay, spitting off tiny fragments that accumulate even on the deepest sea floors. This process works well in most locations around Antarctica where the seas are extremely productive. All species of fish, which in turn feed huge marine mammals like seals, are fed by tiny organisms known as plankton. All of this activity results in debris and dead creatures, which eventually turn into marine snow. However, the Antarctic animals that inhabit this particular rock don't reside beneath a busy water column. They are buried beneath a mile of thick ice, and moreover, they are unable to leave their rock in search of food. According to Griffiths, being stuck in one place in an area where there isn't much food and it's very sporadic is the worst thing. So, how on earth could they be feeding themselves? The food source is traveling horizontally rather than vertically, according to the researchers who believe it's possible that the drift of this marine snow has been turned on its side. The researchers discovered that there are fruitful locations between 390 and 930 kilometers away after studying current charts near the drill site. Even though it might not be much, it's possible that hundreds of miles worth of organic material are traveling through these currents to support these animals. Given that marine snow formed at the surface must fall 7 miles to reach the seafloor in the deepest region of the ocean, the Challenger Deep near Guam, that distance is astounding. Food would have to travel up to 133 times that far, and it would have to do so by floating sideways to get to the animals on this Antarctic rock. Rich Mui, a curator specializing in invertebrate zoology and geology at the California Academy of Sciences, who has extensively studied sea life in Antarctica but wasn't involved in this recent experiment, suggests that this concept isn't too surprising considering our understanding of currents around Antarctica. He explains that as sea water cools in the region, it becomes denser and sinks to the ocean floor before spreading outward from Antarctica. Mui highlights that many, if not all, of the world's current systems are influenced by these movements. He emphasizes that when water flows outward, something else flows in to take its place, leading to an inflow that carries organic matter across considerable distances, possibly spanning hundreds of kilometers. The situation could be a real feast for the creatures stuck on that rock. What's more, the currents might bring in some new species to join the animal community on the rock. But because the researchers couldn't gather samples, they're still not sure about what exactly these sponges and other critters eat. While some sponges chow down on small creatures, others sift through the water for organic debris. Now, that would be quite the headline, says Christopher Ma, a marine biologist at the Smithsonian who wasn't part of the study. Killer sponges surviving in the dark, chilly depths of Antarctica where life shouldn't exist. Since the camera didn't spot any fish or crustaceans, Griffiths and his crew aren't sure if other moving creatures like fish and crustaceans are also hanging out around the rock. This leaves them scratching their heads about whether the sessile animals are at risk of being eaten. Do they all have the same diet, or do some share nutrients? And are there other wandering creatures feeding this colony in some way? Another expedition is needed to unravel these mysteries. The animals don't seem to be at risk of getting buried as the sediment around the rock isn't too heavy. It's kind of like a Goldilocks situation as Griffiths describes it. The rock's location seems just right, with enough food coming in and no predators threatening them, at least as far as we can tell. Plus, it's not getting buried under too much sediment. The discovery of ripples in the sediment surrounding the rock supports the idea that food is being brought here from afar. Moreover, it's unclear how these immobile animals first arrived. Was it something that happened nearby, with them hopping from one local boulder to another? Alternatively, perhaps their parents were on a rock thousands of kilometers away where a more typical marine environment begins. They may have released their sperm and eggs to float in the currents. Griffiths and his colleagues can't estimate the age of these animals since they don't have specimens. Considering the long lifespans of Antarctic sponges, it's possible that this ecosystem is very old. The rock might have been teeming with life ages ago, but currents have likely introduced new life to it over the centuries. Elon Musk, the researchers, and others can't determine whether this rock is unique or if such ecosystems are common beneath the ice. These animal populations might not be a stroke of luck. When the scientists placed their cameras on the rock, perhaps they stumbled upon a regular scene on the sea floor under Antarctica's ice shelves. There's certainly plenty of room for such ecosystems in the 560,000 square kilometers of these floating ice shelves. However, scientists have only explored an area the size of a tennis court under them using earlier boreholes. So, there could be many more of these communities out there, and we just haven't found them yet. This marks the first recorded instance of a hard substrate community, a boulder community, deep beneath an ice shelf, and it seems to challenge all our previous ideas about the kinds of life that could survive in such conditions. The researchers think this colony could be as far as 1,500 kilometers upstream from the nearest source of photosynthesis based on the local water currents. However, until the researchers can get the right equipment to gather samples of these species, a big challenge in itself, they won't learn much more about these animals. Other organisms are also known to get their nutrients from glacial melts or compounds from methane seeps. Moreover, by using a substantial hot water drill, researchers stumbled upon a previously unknown ecosystem thriving in an underground river beneath the icy surface of the Larsen ice shelf. This hidden habitat resides within a sizable chamber approximately 1,640 feet, 500 meters below the ice's surface. After noticing an unusual groove in a satellite image of the ice sheet, scientists uncovered the subterranean structure, although they never anticipated finding anything within it. To their amazement, upon digging down to explore further, the team encountered tens of thousands of small amphipod crustaceans, sparking jubilant celebrations. As a result of this discovery, scientists now possess the most comprehensive understanding to date of the seafloor surrounding Antarctica, including its deepest point, the Factorian Deep, thanks to a newly developed map of the Southern Ocean. The Factorian Deep, discovered in 2019, sits at a depth of approximately 24,400 feet, 7,437 meters below the ocean surface, equivalent to stacking 17 Empire State Buildings from top to bottom. However, prior to this discovery, scientists were unaware of its interactions with the nearby seafloor. The newly developed map, covering over 18.5 million square miles, 48 million square kilometers of the seafloor, is based on more than 1,200 sonar datasets, predominantly collected by scientific vessels. This comprehensive map will aid researchers in identifying any seamounts or underwater mountains that could serve as hotspots for marine life. Finding a way to closely interact with these animals and their surroundings is essential for obtaining answers to our questions, but time may be running out to achieve this. Even though it's tucked away under half a mile of ice, this rock is facing an increasing threat due to global warming. The potential collapse of some of these large ice shelves could lead to the disappearance of a unique ecosystem. Thwaites Glacier in Antarctica, also dubbed the Doomsday Glacier, was observed by underwater robots clinging precariously to the seafloor. If it breaks off, its demise may come sooner than expected due to its rapid pace and a significant increase in ice loss during previously unrecognized phases of fast retreat. Over the past few centuries, the glacier has left a series of parallel grooves on the ocean floor, as revealed by a new seafloor map around the colossal glacial mass. Researchers warned that the excessive heat triggered by climate change could once again accelerate this rapid melting process. Thank you for watching this video until the end. Your support means a lot to us. If you like the content, subscribe, like, and share the video. Your feedback is valuable to us, so don't forget to leave a comment below. See you next time for more interesting content.